Hello and welcome to my talk, Building End-to-End Secure Workflows for Terraform, from Code to Runtime. My name is Scott Ford and I'm Principal Architect of a new security automation company called Mondu. If you like what you hear today, you can connect with me both on GitHub and LinkedIn at scottford-io. Before I get going with my talk, I just want to say thank you to the Hashi community team for putting this event on and for having me. As a practitioner of all things automation and a lot of Terraform, I'm just really excited to be here. This talk is going to start off by framing a very common problem that I see when working with businesses who are looking to integrate security into the end-to-end software development lifecycle. From there, I'm going to introduce you to a new open source security scanner that my colleagues and I released last year called cnspec. And then we're going to put cnspec to work by building an end-to-end workflow with Terraform and a very unique Terraform provider. And then from there, I'm going to provide some next steps if you want to get involved with what we're doing and try this yourselves. So without further ado, let's jump right into it. If you consider a typical automation workflow from left to right, you've got your development stages on the left, and you've got your runtime environments on the right. When it comes to security automation and integrating security into the various stages throughout a software development lifecycle, we've made a lot of progress in recent years. On the left, there are a myriad of infrastructure as code security scanning tools that are being used by platform engineering, DevOps, SRE teams. And these tools integrate nicely into the local development, source code repositories, and throughout CI/CD pipelines. On the right, there's also no shortage of solutions to monitor the runtime environments. Here, security, governance, risk, and compliance teams purchase solutions to help monitor the security posture management, the compliance configuration, vulnerabilities, etc. for the various runtime environments, though the solutions tend to break down between on-prem technology and cloud technologies. And this includes different solutions for things like SaaS security posture management, maybe different solutions for your Kubernetes environments, as well as different solutions for your own on-premise data centers versus a cloud environment such as AWS, GCP, or Azure. The challenges start to arise when the platform engineering, DevOps, and SRE teams are using tools for security that are different than those that the security, governance, risk, and compliance teams are choosing. So for example, if your infrastructure as code scanner can scan the code, but it can't scan the runtime environment, then you've got this disconnect between these two products. And this is common even if it is a infrastructure as code scanning tool that's part of a larger platform. When the security teams and governance, risk, and compliance teams are making changes, say, to the rules that a business needs to follow, how does that trickle down into this infrastructure as code scanner? So this can cause actually overall friction between these two teams and a lot of wasted cycles. We're adopting automation because we want to speed up the process of innovation, but ultimately what happens when they're not aligned is just a blocker between these two sides. You've got on one side, you've got the security, risk, governance, risk, and compliance teams who are accountable for the security of a business. And then on the other side, you've got the platform engineering, DevOps, and SRE teams who are responsible for automating the environments. But this challenge also presents this new opportunity for us to unify this process across these two teams, where we can have one product that can scan both the development cycles, infrastructure as code, source code, CI/CD, but also to all of the runtime environments. And with that, I'd like to introduce you to cnspec. This is our new open source cloud native security tool that allows you to assess all of your business critical infrastructure. It scans both local and remote targets. It's written in Go and runs on any platform, including macOS, Linux, and Windows. cnspec is designed to connect to both local and remote targets to assess the security posture management and vulnerabilities of various platforms. Out of the box, we already work with the major cloud providers, so AWS, GCP, Azure, and VMware, so your vCenter, ESXi clusters. We work with Kubernetes, both managed, self-managed, and managed solutions, EKS, AKS, GKE, OpenShift. We work across container technologies, so assessing misconfigurations and vulnerabilities in your containers as well as in container registries. It works across all the major platforms, Linux, Windows, and macOS for scanning vulnerabilities and misconfigurations. And also, too, the cnspec works with SaaS security solutions, so finding the misconfigurations in platforms such as GitHub, GitLab, Microsoft 365, Slack, and Okta. We even have connectors for on-prem networking equipment, too. So there's just a ton of possibilities with it. The product is extensible, it's open source, anybody can contribute new providers to connect to different technology, and if you're interested in doing that, I'll have some information at the end about how you can add your own providers into cnspec. When it comes to Terraform, think about Terraform as the various stages, right? You've got your Terraform HCL code. Then there is running a Terraform plan where you converge together variables in different configuration before you apply it. And then you apply that configuration to whatever your target is. So these stages as defined by HashiCorp are your pre-plan stage, your post-plan stage, and your post-apply stage. cnspec actually fits into each one of these stages of Terraform. So you can scan your Terraform HCL code, cnspec scan Terraform in the path to your project or a specific file you want to scan. You can generate a plan.json and then use cnspec to scan that plan file. And then also, too, is cnspec can then scan any of the targets. So if you think about automating your cloud environments, AWS, GCP, Azure, VMware, Kubernetes, or even SaaS products, you can scan the code pre-plan, scan that code post-plan, and then use the same tool to actually connect to and scan the environment of whatever it is that you are configuring. And all of this can be done both in local development on your laptop while you're writing Terraform code, but also too as part of any CI/CD pipeline. The easiest way for me to introduce you to cnspec is through the interactive shell that comes with the binary. So it installs on any platform, as I mentioned, and here you can see I've got a project with various Terraform automation code. So I'm going to focus in on AWS, and what I'm going to do on the top here is you'll see I'll connect the cnspec shell to my Terraform project. On the bottom terminal, I'm going to connect cnspec to a remote AWS account. So it's using my local credentials to connect directly to the API of Amazon. When you connect a shell to anything, the cnspec always knows what platform it's connected to. So here you're seeing me run a query that's the asset platform, and I can see on top I'm connected to Terraform HCL, and on the bottom I'm connected to an AWS account. Much like Terraform, cnspec has a concept of providers and resources. So you can see up on top, the Terraform provider has a number of different resources we can use to interact with Terraform code itself. The same thing goes with AWS. AWS is the provider, and below you can see there are a number of different resources that we can use to interact with Amazon Web Services. For example, if I run the query terraform.modules, I'm going to get a list of all of the modules that are in my Terraform project. cnspec also provides the ability to filter any of the resources. Here I'm getting access to all of the configuration for all the Terraform resources, and now I can use this information to zero in on just the AWS instance resources and see how those are configured. Now, a very common rule that we look for is whether or not instances have public IP addresses. Here I can use cnspec to turn a query into an assertion where I'm saying that all of the AWS instance resources should not be configured with this particular associate public IP address. It shouldn't be set to true. Now, on the bottom now, what I'm doing is I'm using cnspec to inspect my AWS account. I can look at all of my EC2 instances, and I can set a query for those, an assertion where I'm saying public IP address, all of them should equal nothing, meaning that no instances should have a public IP. What comes back from this query is an array of instances that actually have a public IP address and are failing this. And this is the foundation for how we can take queries and turn them into rules that we use inside of policies. So let's go ahead and let's take what I just showed you and let's put this to a real world use case. We're going to design an end-to-end workflow that covers Terraform code as well as runtime checking for a specific provider. All of the code that I'm going to be using here is up on my GitHub account. So if you want to follow along yourself, then you can go ahead and clone this down. The provider that I've chosen for this talk is the Terraform provider for Okta. Figure most of us are used to automating our AWS, GCP, Azure environment, so I thought maybe a SaaS security solution might be a good one. So Okta's been working on their Terraform provider, and we're going to use this as an example. Okta's done a good job of providing a baseline of configuration that should be in place if you want to secure an Okta organization. So what we're going to do is we're going to take the Okta Health Insights and we're going to turn that into Terraform code that configures an Okta environment. And then we're also going to write a policy that checks to ensure that both the Terraform code and the runtime environment are configured according to these standards. So what I'm going to do now is we're going to take one recommendation from the Okta Health Insights. This one is, it says sign-on notifications for end users. We're going to use this to design a policy that checks for this configuration in Terraform HCL. So that's pre-plan, then check for Terraform plan, and then the post-apply stage as well, where we'll actually connect to Okta's API and check that the Okta environment is configured. And then from there, it'll be the same pattern throughout. So I'll just show you the finished policy. But without further ado, let's do it. So I've just gone ahead and signed up for a free Okta developer account. You can just head over to developer.okta.com and sign up. And once you're signed up and logged in, then you've got access to a developer account. You can create an API key and you can use that to configure the Terraform provider for Okta. All right, so back to this recommendation that we're going to implement here. So the recommendation here says enable this email notification so end users are informed about new sign-on activity, which can inform them if a different user has signed in to their account. The Terraform provider for Okta provides the Okta security notification emails resource. And you can see that there is a particular argument here that says send email for new device enabled, right? So if this is configured and set to true, then that configuration is going to be put in place. So we're going to go ahead and we're going to use cnspec again. We're going to use the cnspec shell to interact with our Terraform code as well as our Okta development environment. And we're going to set some queries in place that test for this configuration. We're going to do it for Terraform HCL, Terraform plan, and for the Okta runtime environment when we hit the Okta API directly. Okay, so I've gone ahead and I've opened up 3 terminals here. The first terminal, you can see I'm inside of the HashiTalks repository that you can clone down. And I'm going to go ahead and connect the cnspec development shell to my Terraform directory. So cnspec shell, Terraform, and then the directory right here. And if I type asset platform, you can see cnspec recognizes this as Terraform HCL. In the next terminal, I'm going to connect the cnspec shell to a Terraform plan file. So Terraform plan, and then if I look inside the Terraform directory here, there is a tfplan.json. You can generate, output a Terraform plan file to JSON. And again, if I type asset-platform here, you can see that this is a Terraform plan file. And then next up, in the last terminal, I'm going to connect cnspec shell directly to my Okta development environment. Cnspec shell Okta And we'll go ahead and use my organization, and I have my API key configured. And so in this one, and when I type asset-platform, we can see that I am connected to my Okta org. So the first thing that I want to do is we're going to be looking for this Okta security notifications resource. So I'm going to write the query terraform.resources.where name label is equal to this, and we're going to just look at all of the arguments that come back from that. And we can see here are those arguments. So we're going to do this one, send email. So I just need to specify that key here. And when I do that, I can see what the value is set to. And this is where I'm going to now flip this into an actual assertion. We're going to turn this into a true false, and we're going to say .all arguments that are this should equal true, and that I get the value. So this is our first one for the Terraform pre-plan check. The next one for Terraform plan is cnspec has the Terraform plan resources. So I'm going to do terraform.plan.resource changes.where type is equal to, and this is going to be the same thing here. Type is equal to this particular resource, and I get those any of the changes here around that. And again, we're going to be using we can get access to the change after, which is these are all the changes that are going to be applied in the next Terraform apply. And we can see here that we've got access to all of the values here. So it's going to be change.after, and right. So we see the value for that, and we're going to go ahead and again make this into an assertion equals true. All right. So now we've got the value for that. And then lastly here for the Okta organization, I'm going to type Okta organization and see how that is configured. The Okta organization resource provides the security notifications email, and it's going to be Okta organization.security email notifications, right? So there's that specific configuration, but I need it to get for new device enabled right there, and we're going to set that into an assertion here, and that's true. All right, so now we've got 3 different queries with cnspec that we're going to use as part of our policies. So this is our pre-plan check, this is our post-plan check, and this is our runtime check. Okay, so I'm in the HashiCorp secure repository here. I've got some policies. This is some example policies. This is the one that I'm going to take you through right now. We're going to put those 3 queries that we just did in the last section into a policy, and we've got the Terraform directory. Now this is working Terraform code, so when you clone this down, if you configure the provider, it will work for you against an Okta environment. So let's just take this one example right here. So cnspec policies are put together using YAML. And just to go from top to bottom here, you've got policy has a UID. It's a unique identifier. You can give it a title. They're versioned artifacts. You can have licensing information. There's some tags, tagging strategies you can put in place, author, etc. This first section on docs is around the documentation for the policy itself. What's the rationale behind this a given policy? The next section right here is groups of checks. So if you had, like, let's say different types of services, you wanted to group together the checks for, maybe something around users versus groups versus MFA, whatever it is, you can use groups to put that together. You can see right here, we've just got this one check, which is our Health Insight enabled sign-on notification emails for end users. That's a unique identifier. And then there's this next section, queries. Now this is where you compose all of the checks. So we can see here, this UID is defined right here. It has the title. It has an impact score. So according to Okta, this is a high impact check. So I put a level 80. I'll provide documentation about where you can define what each of the impact levels are. And then there's a separate documentation. This is for this specific check, right? So it's just the rationale for the check. And then unique with cnspec policies is you have this section called variants. And variants allow you to provide different ways to check for a specific recommendation. So you can see I'm using the same UID, except for at the end of it, I've got Terraform HCL, Terraform Plan, Terraform Runtime. These are arbitrary, but that's just how I named it. And then, so we go to this first check for Terraform HCL. And we've got the UID for that. You've got the title, but this time I also included Terraform HCL. Same impact. And then this is also very unique. A filter is how you determine when a check should be applied. It will only be run if cnspec matches that the asset platform is Terraform HCL and this specific query, that this particular resource exists, right? So this means you can point it at different types of Terraform projects or, mixed mono repos, things like that, and it will only run against the specific type of platform and the specific resources that are defined there. So, and then finally, it's the query itself. Like this is the query we did in the last section. So same thing goes here for Terraform Plan. It's all the same except for the filter. The filter here is it's only going to run if the asset platform is Terraform Plan and that this specific plan file has this type of resource. And then lastly, for the asset filter for runtime, it is just going to run if it is against the Okta org. So let's go ahead. I'm inside of my shell in VS Code, and I'm going to go ahead and run cnspec scan Terraform and my Terraform directory, and I'm going to pass the file name. So policies, if I run that, you can see it passes because our HCL code actually has this set to true. Now, if we wanted to test this out, and just say flip this thing to new device set to false, as an example, scan it, and it's going to fail. Right? So we're good. That checked. Now we'll go ahead and we're going to run a check against Terraform Plan this time. So scan Terraform Plan, and I have a plan.json already generated. And there we go. So we're checking the plan file. So any of the next changes are being tested. Finally, we're going to go ahead and check the runtime check. So cnspec scan Okta and organization, and this is going to connect directly to the API of Okta and scan it. Now you'll notice too that at the end of each of these runs, it's asking me if I want to generate a report. cnspec, if you allow it to, will generate a report of a scan and publish this up to the web, and you can then go ahead and share this out however you want. So this has the particular check that was just run and the results of that check as well. So if you have a policy with lots of different checks, then it's going to publish that all out and you can share that around. Okay, so to put this all together, the repository also includes a GitHub Actions workflow in here that takes you through a number of different stages. We're going to do the same things we did locally, but we're going to do it using GitHub Actions. So we do some Terraform pre-plan validation, then we scan the Terraform HCL pre-plan, then we go through and we generate a plan file here, and then we go ahead and scan that plan file. Finally, we come and we actually apply the changes to the Okta environment. And after we do that, then we execute a scan of Okta just to show that the runtime environment has been scanned as well. So let's go ahead and let's kick this pipeline off and let's see it run. All right, so first of all, we're doing a little bit of Terraform validation, Terraform format, etc. Then we're doing a pre-planned scan of our Terraform HCL. Next up, we're going to go ahead and we're going to generate that plan file.json. And once that's generated, then we'll go ahead and we'll do a post-plan scan of the JSON file. And then finally, once that JSON file has been scanned, then we're going to do an apply and then scan the organization. Now note, you can always set up thresholds too for the scores of these policies. So if for some reason you wanted to enforce the policy and you actually wanted to stop a build from passing, if it doesn't meet the score threshold, that's easily configurable with cnspec as well. And with that, we have our end-to-end secure Terraform workflow that goes from code all the way through to runtime. We could do the same thing in local development that we can in CI. It's the same tool throughout the entire process. All right, and to wrap this all up, cnspec is an open source security scanning tool. It fits into every stage of the software development lifecycle, from local development through source control, CI/CD of any kind, and into any runtime environment. cnspec works with a number of different technologies: Terraform for infrastructure as code, Kubernetes manifest, and also a ton of different infrastructure in runtime environments. This is extensible. We have a lot more plugins coming for cnspec. So if you're interested in getting involved, we'd love to see you jump into the community and start to be a part of both cnspec. Ultimately, what we're trying to do though is bring closer collaboration between these platform engineering, DevOps, SRE teams, along with the security, governance, compliance, and risk teams as well. So that's ultimately how we're all going to get better at this practice of security automation. cnspec, you can find it at cnspec.io. You can download it for your platform. You'll find documentation there, information about how to get involved in the community. Definitely join up in the community. Come find me. I'd love to collaborate with you on any projects you're working on. Note too that cnspec has kind of a sister project as well called CN Query, which is cloud native asset inventory. So you can use CN Query to scan into your environments using those same queries to gather specific data. We've got some great starter content around this as well. We also have the Open Security Registry. This is where you can find certified policies that are already available for you to just enable and customize. There's CIS benchmarks, there's security best practices, just a ton of content up there. You'll also find open source query packs, so the asset inventories for CN Query. Lastly, we've also have a cnspec plugin for Packer. So if you're building your base images and you want to scan those base images for misconfigurations and vulnerabilities, you can do that with this cnspec provisioner. So with that, I just want to say thank you very much for joining into this talk. If you like what you saw, please reach out and contact me. I'd love to collaborate with you, and happy coding.